what's called the binomial distribution, okay, or the binomial probability. Binomial probability. Now let's talk about what this is. The prefix bi, in case you're wondering, you English people out there, the prefix bi means two. Okay, so two outcomes for this. There is a what mathematicians called a success or a failure. Okay, so you got a success or you got a fail. So, and there's probability associated with it. Okay, and the other thing that's true about this is the outcomes are independent. So what that means is they don't matter. Like there's no recalling. They don't affect each other. You always have the same success or the same failure. We could use this in the kind of the coin flipping thing. Like think about flipping a coin 3 times, right? And for example, if you were going to flip coin 3 times, and I want to know what's the probability of getting 2 heads and 1 tail. Now I don't care about the order, I just care about getting it. Well, so one of the things that you can think about would happen is that we could do a tree diagram on this. And with the tree diagram, we could say, okay, well, we could get a head, or we could get a tail. We could get a head, or we could get a tail. We could get a head, or we could get a tail. And we could do this on all of these branches, right? And you can see like right away that with this, you can think about like which ones get this 2 heads and a tail. This branch would do it. This branch would do it. And that branch would do it. So there's 3 branches. And each of those branches, if you remember from what we did with our work previously, is notice that it's 1/2 times 1/2 times 1/2. Each one of these branches has a 1/8 chance. So this one is going to have a 1/8 chance, and this one's going to have a 1/8 chance. If we add those up, 1/8 plus 1/8 plus 1/8, we get 3/8. And that's our answer. Now that's easy enough when we're flipping a coin only 3 times. But what happens if we flip a coin 7 times? And I now say, what's the probability of getting 2 heads out of 7 flips? That would be a little bit more problematic, right? I mean, that would make it a much bigger tree, right? So if you think about like this tree diagram has, you could get a head and then a tail and then you can get a head and then a head and then a tail. You could get a head and then a tail and then a head, or you get a tail and a head and a head. So there's 3 ways. Okay, there's 3 ways on this. That's the same thing as taking 3, choosing 2 heads. If you remember back to the last thing, that's what that gives you. 3 choose 2 is 3. Each of these things has a 1/8 chance. So what we could have done is we could have done 3 times 1/8 to get our 3/8. So we could have made it a little faster that way. Now let's say we make this a little bit harder, right? Let's say I make a new problem, and on this new problem, I say, you flip a coin 7 times. What's probability of getting 2 heads? Now, if we had to make a tree diagram for this, it would be a nightmare. If we had to make a list, that would be tricky as well. Think about making a list. You'd have heads, heads, tails, 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 tails. And then you'd have to make a new one. You know, you maybe go tails, heads, heads, tails, 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 tails. And we'd have to keep going with this. That would take a long time. But when we got done, what we'd have, we'd have 7 things. We would choose 2 of them to be heads. We could do that on our calculator, right? We could do that really quickly on our calculator. If we did that, let me go over here, and if I go to here and I go 7, choose 2, it'd be 21. So my list would have 21 things in it. Now notice, each of these things, heads, heads, tails, 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 1, 2, 3, 4, 5, all has the same probability. 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Notice that that is 1/2 to the 2nd power, and then another 1/2 to the 5th power. Now we could calculate that as well, right? And we could do that on over here. We could do 1/2 times, let me go back here. Let me put a parenthesis in here. Parenthesis here, and let me raise it to the 2nd power. And then I do times. If I do 1/2, oops, 1/2 to the 5th power, I get that value. You know, it's roughly 0.007812. If I multiply those 2 things, I would get that probability. 21 times 0.007812. That would get me that probability I'm looking for. If I take this and I multiply it by 21, I'd get, maybe we'll go back over here, 0.1640625, or roughly 16%. That's the answer to this question. Flip a coin 7 times, what's the probability of getting 2 heads? About 16%. Okay, so let's say we make it a little bit different. Let's say that, you know, in this case, let's say we're somebody's, let's say the probability that it's going to rain on any given day is equal to 0.21. And the probability that it's not going to rain would be equal to 1 minus 0.21, because either it's going to rain or it's not going to rain, or in that case 0.79. Okay, and we're going to think this is utopia. It's either going to rain or it's not going to rain. There's no in between. So if I want to know what's the probability that out of 9 days it will rain 3 times, 3 days. Okay, so it could rain the first 3 days and be dry the next 6. It could be dry the first 3, rain the next 3, be dry the next 3. So there's an order to it, right? So what we're going to do is we're going to do the following. We're going to calculate it by saying, okay, we got 9 days. We're going to choose 3 of them to rain. The probability that it's going to rain is 0.21, and it's going to rain 3 days. So this is the rain days times the 0.79 that it's not going to rain, but that's going to happen 6 days. If we calculate that, that will give us our final answer on there. So if I go over here to my calculator and hit enter, and I do combinations, and I go over to my main, and I do 9 here, I do comma 3, close that parenthesis, times, now if I do 0.21, if I need an exponent, I can hit this b here, raise that to the 3rd power. I do need to get over, I do times 0.79, because that's the days it's not going to rain, and I got 6 of those. And what I find out is my answer is 0.189103565 7, something like that. If you feel good, jump onto Delta Math. If you don't, watch the next video for more examples.